Hello students, welcome to new video on basic interview questions for structural engineering. Today we will discuss about basic interview questions on columns. This is useful for civil as well as structural engineering students to appear for structural engineer post or structural engineer interview. What is column? A column is a vertical structural element in the engineering structures. It is a vertical structural element in engineering structures which supports the entire weight of structure and distribute that weight to the foundation of structure. So that structural element is called as column. I repeat again, a column is a vertical member or vertical structural element in the engineering structure that supports the entire weight of structure and transfer that weight to the foundation of that structure. So that vertical element is called as structural column. If you look at these sample images, sample examples, this red color vertical member is called as column. Here also this is column. All these vertical members which supports the load of the structure is called as column. These are all columns. Now what are the types of columns? If you consider the geometry of column, there are two types, rectangular column and circular column, because the cross-sectional shape is circular here and here it is rectangular. It is based on geometry of cross-section. Then based on the load acting on the column also, column can be classified in two types. First one is axially loaded column. In axially loaded column, the axial load is acting exactly at the center of column. That is called as axially loaded column. And if load is not acting at the center, if load is acting away from the center, for example, load is acting here, so it has some eccentricity with respect to center line, like this E. Eccentricity is represented as E. So if load is not at the center, eccentric load is acting on the column, that column is called as eccentrically loaded column. Also, if column has a reinforcement, we can call it as a reinforced concrete column. So these are the various types of column, but whenever this question is asked in the interview, what are the types of column, the most expected answer from the students are whether the column is long column or short column. So these are the two important types of columns, long column and short column. Now how to define long column and short column? So it depends on the ratio of effective length of column to its least lateral dimension. Okay, column has cross-sectional dimension. This is width and depth. Two dimension column has. So out of width and depth, whichever is small, it is called as least column dimension. In the cross-sectional dimensions, whichever is small, width or depth, so smaller dimension is called as least column dimension. So now if you take the ratio of effective length of column to least lateral dimension, if this ratio is greater than 12, then it is called as long column. And if ratio of effective length if ratio of effective length of column to its least lateral dimension is less than 12, it is called as short column. When this ratio is greater than 12, it is long column, less than 12, it is short column. You can define long column and short column based on the some other ratio also. For example, the ratio of effective length of column to radius of gyration, that is represented as a rho. So effective length of column to radius of gyration, this ratio, if it is greater than 40, it is called as long column, and if it is equal to 40 or less than 40, it is called as short column. So whenever in interview, if a question is asked on what are the types of column, you should always answer that column can be long column or short column. Then what is criteria for long column? So you can say that if effective length of column to its least lateral dimension ratio, if it is greater than 12, it is called as long column. If it is less than 12 or equal to 12, it is called as short column. Another way to define long and short column is if ratio of effective length of column to radius of gyration, if it is greater than 40, it is a long column. If it is equal to 40 or less than 40, it is called as short column. Then failure reasons of column. Column is failed because of two main reasons. First one is a failure because of crushing and second is failure because of buckling. So mainly short column is always fail because of crushing and long column is always fail because of buckling. Buckling means when the axial load acting on the column will subjected to lateral deflection. This is center line if you consider. Because of this load, column is subjected to this lateral deflection and this shape is called as buckling shape or buckled shape. When column is undergoes the permanent buckling deformation, the load at which the column undergoes the permanent buckling deformation, that load is called as critical buckling load. Here it is written, a load at which column undergoes permanent buckle deformation is called as critical buckling load. Another point to be remember that long column absorbs always less horizontal force, whereas short column always absorbs more horizontal force. Okay. Now there is one more important point to be remember about the column and that is called as effective length of column. What is effective length of column? So effective length of column means it is the distance between 2 points on the column where the bending moment is 0. Distance between 2 points on the column where bending moment is 0. Now if you look at this two end pin or both ends simple, bending moment is 0 at the ends. So it means distance between both ends is nothing but effective length of column. Okay. But now for other boundary conditions, if you look at, the bending moment is not 0 at the ends. So how to define the effective length for other boundary conditions? So for other boundary conditions, or you can say the effective length of column can be defined as it is the length of an equivalent pin end column. Equivalent means if you replace other boundary conditions by two end pin column. So it is a length of equivalent pin end column having the same load carrying capacity as the column under consideration having. So whatever load carrying capacity this other boundary condition column having, if you replace this other boundary condition column by two end pin end column having the same load carrying capacity, but the length will be different. So whatever length is changed, that change length is called as effective length. If it is difficult to remember, the second definition is simple to remember. It is the distance between 2 points where bending moment in the column is 0. Okay. So now if you look at this image, this figure, first case is both end simple, both end pin. So effective length of this column is called as LE. LE is effective length and L is the actual length. So LE equal to L. Effective length is equal to length of the column. But if it is a cantilever column, effective length is equal to 2L. L equal to 2L. It is twice length of column. What does it mean? It means if you want to find out the critical buckling load of a cantilever column, since the Euler's formula is not developed for cantilever column, you have to draw equivalent column of two end hinge, which gives you same buckling load what cantilever column has. But now if you replace this cantilever by two end simple column, then length of height of the column you have to change, and that change in height will be 2L. So if it is L, this will be 2L. So this length is called as effective length. Okay. Similarly, effective length of two end fixed column, it is L equal to 0.5L, and for one end is fixed, one end is simple, that is called as fixed pin column. the effective length is equal to 0.7 L or 0.699 L, means 0.7 L. So effective length formulas are always asked during the interview examination. Effective length of simple column L equal to L, effective length of cantilever column L equal to 2L, effective length of both end fixed column L equal to 0.5 L, and effective length of one end is fixed, one end is simple, effective length of that column is 0.7 L. And Euler's formula to calculate the buckling load, that is PCR equal to pi square EI divided by LE square. This is given in all the books of strength of material. You can refer that. LE means effective length square. This is Euler's formula to calculate the buckling load. This formula is given here for all the boundary conditions. Simple ends, fixed and free means cantilever, fixed, both end fixed, one end fixed, one end pin. So these are the formulas of effective length which you must remember. Then what is difference between long column and short column? So already we discussed few points. For long column, the ratio of effective length to least lateral dimension is greater than 12. In short column, that ratio is less than 12. Effective length to least lateral dimension. In long column, ratio of effective length to radius of gyration rho, it is greater than 40. In short column, that ratio is either equal to 40 or less than 40. L by rho is less than 40 or equal to 40. In long column, failure is caused because of buckling phenomena. In short column, failure is caused because of crushing phenomena. Buckling tendency of long column is very high, whereas buckling tendency of short column is very low. Load carrying capacity of long column is low compared to short column. Short column has high load carrying capacity. Radius of gyration for long column is always less, whereas radius of gyration for short column is always more. And last point is buckling stresses induced in the long column and direct compressive stresses are induced in the short column because short column does not buckle. So stresses induced are direct compressive stresses, and in long column stresses induced are buckling stresses. So as a structural engineer, whenever you will appear for an interview, you must prepare this point related to columns. What is short column, what is long column, right? Failure phenomena, failure reasons of columns, effective length of column, right? These are the important points to be remembered for the columns. In the next class, we will discuss the next article on fundamental interview questions for structural engineering. Thank you very much.